Many students find linear programming confusing and believe that solving an LPP is difficult. However, once the problem is represented graphically, the concept becomes clear and much easier to understand. Every method used to solve the LPP follows specific steps, and with proper focus, these steps become simple. In this video, we will discuss graphical method, one of the method to get the solution of LPP, and break down the graphical solution method step by step. Hello everyone, welcome to my channel Decode Data with SKD. I am your professor Dr. Shashikant Dikshit. Before we begin, I sincerely thanks all of my subscribers for your continuous support, and your encouragement motivates me to create more content like this. I hope I will get the same support in future too. So let's understand the method to solve the LPP. In operations research, many real life problems involve optimizing resources under certain constraint. One of the simplest and the most effective method to solve such problem is the graphical solution method. This method helps us the constraint, visualizing how the constraint interacts and how the optimal solution is obtained. In this video, we will learn the step-by-step graphical approach to solve the linear programming problem and understand how the optimal solution is identified. Before starting with the graphical solution, let me just detail you about the different type of methods available to solve linear programming and when we use these methods. So normally we have four common methods that we use to solve the linear programming problem. The first method is called the graphical method. In case of your problem, normally we have the decision variables. If we have only two decision variables in our problem, we can use graphical method. What it means that you cannot use the graphical method if you have more than two decision variable in your linear programming problem, right? So this is one of the restriction when we go for graphical method, right? The second method is called the simplex method. Of course, the name is basically it's a simplex, but it's a bit difficult method. And when we use this method, when we have more than two variables and the constraints are less than equal to in nature. So if you have the constraint where the constraints are less than equal to in nature and you have more than two variables, you can use the simplex method. In future slides, of course, I'll tell you the how to apply the simplex method too. The third method is called the big M method. Big M method is one of the method to solve the LPP, and in this method, when the constraints are greater than equal to or equal, we use big M method. And the next method is called the two-phase method. Two-phase method is same as big M method, where we have greater than equal to constraint or equal constraint, and normally we use artificial variable to be introduced to make the equation in equality, sorry. So these are the four methods that normally we use when we go for the solution of linear programming problem. Now, in my previous video, I've already explained the model for linear programming problem, right? So what we normally do is when we have a linear programming problem, we first formulate the model, right? And model is having certain structure. So let me again give you that we have a decision variable, let's say x and y. We have objective function that is either max z or min z with some equation. Then we have constraints that is subjected to. So we have two constraints, right? And then we have non-negative constraint that is x is greater than 0 and y is greater than 0. Now let me first explain you about the previous slide, that when these methods are applicable. Now in this case you have only two variables, x and y, so you can use the graphical method here. In this particular case you can use the graphical method, right? Now when you have more than two variables, let's say you have one more variable called z. Now in this case you cannot use the graphical method, right? Now you have to select from the rest of the three methods. One is called simplex method, second one is called big M method, and third one is called two-phase method. Now simplex method is used when we have more than two variables and the constraints are less than equal to. So in this case constraints are less than equal to. So now in this case, because we have three variables x, y, z and constraints are less than equal to, we can use the simplex method, right? Now that comes to the big M method and two-phase method. So same condition, you must have more than two, so you have three variables, and if these constraints are greater than equal to, right, greater than equal to, then you can use either big M method or two-phase method. Both the methods are applicable, right? So now I think it's clear that when we use which different type of method, right? Two variable, simple graphical method. More than two variable and constraints are less than equal to, simplex method. More than two variable and constraints are greater than equal to, big M method or two-phase method, right? So this is what. Now let's start how to find this solution with the help of graphical method. Let me just remove this one. So right, fine. Now what we do is, suppose this is, of course this is a problem with two variables, right? So what we will do is, we will first of all take the step one where we change the constraint into the equality, right? So these are the constraint. Now we have to change this into equality. Now this is right now, this sign represent the inequality, right? It's not equal, right? So we have to convert this into equality. So what we do is, we'll say x plus y equal to 6 and we'll say x plus y equal to 9. Fine. This is called the equality. Now, so we have converted this into equality. Simple. We have changed the sign, nothing else we have did. Now this is equation 1 and this is equation 2. Now the second step is, in step 2 what we do is, we find out the line coordinate. So how we have to find out the line coordinate? What we do is, we'll take the equation 1, right? So this is the equation 1. In this equation, first we'll say x is equal to 0. So when I'll put x is equal to 0, y will be 6. Y will be 6, right? And in same equation, when I'll say y is equal to 0, x will be 6, right? So we'll put first x is equal to 0 and then we'll put y is equal to 0 in same equation, equation number 1, right? So we have 6 and 6. Equation 2, what we do is same. We'll put x is equal to 0. So we will get, now let me just solve it. X plus 3y is equal to 9. So if I say x is equal to 0, it will be 3y is equal to 9. So y is equal to 9 upon 3. So y is equal to 3. So we have 3. Same, when I'll put y is equal to 0, so this will, and this entire will be 0 and x is equal to 9. Right? So this is, so what we did in the first step, we'll make it equal. Second step, we'll put x is equal to 0 in equation 1, y is equal to 0 in equation 1, x is equal to 0 in equation 2 and y is equal to, right? Now when we do this, we will find two coordinates, right? For line 1, 6 and 6, and for line 2, 9 and 3. 6 and 6 and 9 and 3. Because x is 9, so x, we will write x, normally we will write x, y. So because x is 9 and y is 3, so we will write like this. So 9, 3. Now these two coordinates I am having with the help of my constraints. Hope up to this point things are clear to you, right? Now what we will do is, based on this 6 and 9 here, 6, 6 and 9, 3, we will draw the line. Now, this is what basically the x-axis and this is what the y-axis, right? Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, 1, 2, 3, 4, 5, 6, 7, 8, right? Now let's say 6, 6. So this is the 6 and this is 6. So what we'll do, we'll basically join these two, 6, 6, right? Then x is 9. So x is 9. This is 9 and y is 3. So this is 3. So we'll join this. Now we have two coordinates, two lines, and both the lines are drawn. You suppose you have, like in this situation, we have only two constraints. So we have two lines. If we have 10 constraints, you will have 10 lines, right? Now, once you draw this, now you have to move down to just now. Now, what you have to do is you have to move down to equation. Now, this is basically the equation 1, line for equation, and this is basically the equation for 2, right? Now let's see what is the sign. This sign is basically less than equal to, right? So this is equation 1 and less than. So less than is always towards the 0, this side, right? And greater than always towards this side. So less than is this side and greater than is this side, right? So this is what we have to keep in mind, right? So if I'll say less than, it means I am talking about moving towards 0. If I'm talking about greater than, I'm talking about moving towards higher side, right? Now, because this is less than equal to sign, so I'll just mark one arrow in this towards 0, right? Fine. Now in second line again, we have the same. So what we'll do is, in second line, this is the second line, so I'll mark. So I have basically marked two arrows in this, right? Once I'll mark the arrow, now I have to find the common area, right? Common area for these lines. Now, how you will find the common area? Now we have area 1, we have area 2, we have area 3, right? And 1, right? 1, 2, and 3. Now, if I say, is this 1 is common in both the lines? No, because this is saying towards lower side. This arrow is saying towards lower side, whereas this area is above this line. So this should not be common area. Same in case of this one. Is this third is common area? No. Why? Because this area is towards this side, whereas the sign is towards lower side. So it cannot be common area. This is the area that is basically the common for your problem. So this is you have the common area. Fine. So we say this is basically the common area that belongs to both the lines. So we have find the common area. Now when we have find the common area, now what we have to do is we have to find out the intersection point on the common area. So we have one intersection point, we have the second intersection point, and we have the third intersection point. They are the three intersection point in the common area, right? Now once the common area and the intersection points are identified, we'll find the coordinate for this. So for this particular point, the coordinates are 0, 3. So x is 0 and it is 3. Now for this one, let's say coordinates are 4.5 and 1.7. So how we'll do? We'll basically draw one line from here, perpendicular line, and then one line here, right? One line. So this says it's something around 1.7 and this says something around 4.5. So this is basically line, right? Now, because I am drawing the rough graph, So might be this coordinate may change. Right? When you talk about these coordinate may change, because if you draw in graph, you'll get the right coordinates, right? This is what you have to keep in mind. And the third one is basically the one in which 6 and 0, so x is 6 and y is 0. So now we have three constraints in this, right? So what we did, after getting the coordinate of the line, we have basically the graph, and which we'll draw the line, we'll find the common area, and we'll find the coordinate of the intersection point or in common area, right? Now, so this is what we did, this is what we find. And now once we'll find these coordinates, coordinate 1, 2 and 3, now what it means, we have three solution for this particular problem, right? We'll take the objective function to get this solution, right? So my first solution is 3, 0. So what I'll do is I'll take this one and put the value of 0 and 3. So x will be 0 and y will be 3. So this will become 0 and this will become 6. So answer will be 6. Same as 4.5 as x and 1.7 as y. So you will get 16.9. And for third one, x as 6 and y as 0. So it will be basically 18, right? Now, because the problem is of maximization, whatever is basically maximum between these three will be the answer. So now the answer is 18. So maximum profit will be 18,000 rupees, whatever it is, right? Now, how you will conclude this? You will say the result indicates if we produce the unit of 6 unit of A and 0 unit means will not produce B, in this condition we will earn the optimum profit of rupees 18, right? So now this way what you can do is you can solve your graphical method. Fine. So thank you very much. I hope you are able to understand how to solve the linear programming problem with the help of graphical method. Now you can comment your questions and you can share your thoughts in comment box. And if you really find that this particular video helpful for you, please like this video, share this video with your friends, students and professionals, and also subscribe so that you will get the data, you will get the videos in future related to data science, research, statistics and MBA concepts. In my next video, I will come with one of the method called simplex method to solve the linear programming problem. Till then, thank you very much for watching my video. Request you to subscribe my channel Decode Data with SKD and write your comment. This will help me to understand my mistakes and help me to correct it also. Thank you very much. Enjoy your day.